So we're going to run program RowOPS to help us find the inverse of this matrix. To find the inverse of this matrix, we first have to input this matrix, that is matrix A, side by side with the identity matrix of the same dimensions, that is 2 by 2. I have that in matrix B. So there it is in matrix B. So we're going to run program RowOPS to help us out with that. And I selected matrix B. Now the overall goal in working with program RowOPS here is to make the left-hand side look like the identity matrix, that is the right-hand side. So through these different types of operations, I want to make this a 1, 0, 0, 1 on the left-hand side. So does anyone see a clever way I can start? Some way that I can get a 1 in the first digit here? Yeah, if we add the first row to the second row, that'll put a 1 here. But that's a nice, clever way to get a 1 here without having to resort to any fractions. The alternative is to multiply the first row by -1/7. Then I'll have a 1 here. Multiply the first row by -8 to get a 0 there. That's fractions. So our goal is we're going to multiply this by 1 and add it to the second row. So that's going to be a multiply row add. I could probably just do row plus. I think that would work as well. Yeah, because all you're adding one row to the next. So let's try that. Add first row to the second row. There you go. That was quick. Now, if you're not comfortable with that, you could always multiply row 1 by 1 and add it to row 2. But this is what I wanted. Now, the other thing that I want is that I want to put that 1 in the upper left-hand corner, so I need to do a row swap. So let's do a row swap. That's just going to be the first command here. So press enter or type the number 1. Swap the first row with the second row. Okay, not too bad. So we're in good shape here. I need to get a 0 here next. So that would be multiply the first row by 7 and add it to the second row. So let's do that. Multiply row add, it's the fourth option down. Multiply row 1 by 7, add it to row 2. Looking good there. Let's keep going. Let's make this a 1 next. What would I do to make that a 1? Multiply by reciprocal, right? Which would be -1/3. So we're going to use multiply row. So the third option there. Multiply row 2 by -1 divided by 3, and you just type that in. You don't use a decimal. Don't use -0.33 or something like that. Just type in the exact fraction. And notice it gives us something that involves fractions, but at least we got a 1 here, which is what we wanted. There's one last step here. I need to make that a 0. So what can I do to make that one a 0? I need a 0 here. Yeah, add row 2 to row 1. So again, you could use star row plus, or you could also use add row. So let's use this one just to practice it again. Second option down. We're going to add row 2 to row 1. So you start out with the row you're adding, and then you finish with the row you're adding to. So we're adding to row 1, and bam. There you go. There's your inverse matrix. Love this program. It's a lot friendlier than doing it by hand. A lot friendlier. So overall, the inverse is -5/3, -4/3, -8/3, and -7/3. So that's our inverse matrix. I doubt I'd give you something that would involve fractions. Yeah. The interesting thing is that the matrix and the inverse commute. That is, if I did A inverse times A, it'd be the same thing as A times A inverse, and either one of them is going to give you the identity matrix. You're going to get, ones on the main diagonal and zeros everywhere else. Let's try problem number 18 here, which asks you to find the inverse of this matrix. So to start that, you would input this matrix, which would be what? What's the dimensions of this bigger one here? Good. That's going to be a 3 by 6 matrix. 3 rows, 6 columns. Now, prior to starting this video, we already input that. Let's just double check that it's there. So I'll exit this. And it says select a matrix. I think I put that in matrix C for myself. Let's just take a look. And yeah, that looks pretty good. So again, the goal is to make the left-hand side of this look like the right-hand side. Make it look like the identity matrix. What would be a good first place to start? What would you do first? Perfect. Swap row 3 and swap row 1. So let's do that. So it's going to be row swap, so the first option down. Swap row 1 with row 3. Beautiful. That's a great start. With us? Okay, good. Everyone's up to speed here, right? Now on the test, I'm going to want you to kind of record your work here, so you could do something like row swap 1, 2. Be something you could write. Let's keep going. What would we do next? Yeah. Ooh. Yeah, oh, wow. You're right. I don't have the exact right matrix here, do I? All right. Well, just follow along on your calculator doing similar calculations that I have. Yeah, you're right. That should be 4, 2, 4. Wow. I really... No, 3, 3, 2. Yeah, that should be a 4 here. Okay. Boy, I wonder if that's going to screw things up. Oh, man. It might. It really might. So what I'm going to do is I'm going to quit this now, edit that, and restart it here. All right. Stop. So quit. Let's go edit that matrix real quick. Yeah, I'm worried that that would change things enough that it would make it a pain. So that should be a 4 there, right? That was the problem? Yeah. Okay. So let's rerun this. And select matrix C. Row swap 1 and 3. There we go. All right, let's keep going. Let's get a 0 here and then a 0 here. You want to do it in this order. 0's here, here, and then there. So I'll start with the one below this. What would I do to get a 0 here? If I want to get a 0 where the 3 is. Good. So let's do this. -3 times row 1 plus row 2. Just to kind of record our work here. So multiply row 1 by -3, add it to row 2. What should I do next? Perfect. So -4 times row 1, add it to row 3. So again, fourth option down, multiply row 1 by -4, add it to row 3. Okay, looking good. Now, personally, I like to avoid fractions, and it'd be nice to have a 1 right here. Can anyone see a cheap, easy way I can get a 1 here? Row swap would exactly do it. It's close. Row 3 by what? -1. Yeah, if you multiply row 3 by -1 and add it to row 2, we can avoid having to deal with fractions, at least for a little while longer. So let's do that. So it's going to be -1 times row 3 added to row 2. So the row you're adding to always goes second in the way we're doing things here. So multiply row 3 by -1 and add it to row 2. And bam, that's beautiful. I got a 1 there. I'm in good shape. Let's keep going. I need to get a 0 here. How am I going to get a 0 there? Not by row 1. Thank you, ladies. So -2 times row 2 added to row 3. And that's going to put a 0 here. The order in which you get the zeros is important. I would copy the order in which I'm getting zeros in your work. So multiply row 2 by -2 and add it to row 3. Great. We're looking good. Now eventually, we're going to need to make this a positive 1. But before I do that, let me notice that, gee, if I add row 3 to row 1, I can get rid of that altogether, right? So let's just do that now. Let's do add to a row. So I'll pick the second option. First row that you're adding from is 3, and the row that you're adding to is 1. So row 3 plus row 1. Almost done. What's the last thing we got to do to get our inverse? Yeah, I'm going to multiply this last row by -1, so -1 times row 3. That should be our last step. So that's a multiply row, so it's a 3 here. Multiply row 3 by -1. Nice. So your inverse matrix, A inverse, is, let's see, 3, -2, -5, -1, 1, 1, -3, 2, and 6. So that's your inverse matrix. It's just the right-hand side of this. Are we okay so far? Now let me show you a little cute trick that you can do to kind of double-check things. I have no problem with you double-checking things, but if you want credit on these types of problems, you need to show me your steps here. And I'll give you a friendly example to work with when I'm testing you. But let's exit this program. So quit the main and press 7 again. You should get a nice see ya from somebody that you know and love. Then let's go back to our matrix. So I had mine in matrix C, and I'm going to edit C. So I'm all done with that extra 1, 0, 0, 0, 1, 0 part, that extra identity matrix part. So let's do this. Let's now make that a 3 by 3 matrix. So come over here, make that a 3 by 3 matrix. So enter a 3 here, and guess what? It's going to chop off that extra part there, right? So now all we have is the matrix. And let's go print that matrix out. Let's say second matrix. So you can see that. But this next time, second matrix, 3, hit the inverse key, right? So the inverse key is right there. So C inverse, booyah, should look familiar. That's exactly what we calculated for our inverse matrix. So that's a nice way to double check yourself. I encourage you to double check yourself. I want you to get these things right. So take just an extra, what? It took like 40 seconds maybe to make sure you got that one right. How are we looking on inverse matrices? Doing okay?